on top over here. I call this our alpha point, and I have the other point over here, and we have a beta point, right? So you can see alpha. So we know, and then before I go any further, I'm going to draw another line. Okay, I'm going to draw a chain line. Okay, so this is our chain line. And this chain line is known as our centroid. Okay, so you all now know what is a centroid. Like before our class starts, someone was asking about the centroid. How come, why we never find the centroid or the Y bar and the Z bar? Okay, so that is our centroid. Okay, so the distance from the centroid, okay, so from the centroid to over here, this is our Y what? Positive, and then beta point is our Y negative. Okay, so if we want to find, right, we now apply the formula. Okay, we want to find the stress in the x direction, okay, at point alpha, right? So this is equal to what? So if we go to apply the formula, we know that this has to be minus mz, right, over izz, right? And we now know when we are going to look for point alpha, y is what? Positive. So this is y positive. Okay, so the formula is equal to minus mz over izz multiplied by y, right? So the minus over here states that the stress is in what? Compression. Which is true. If you look at point alpha, it is under what? Compression. Okay, and then if you were to now do stress x beta, right? So it's still minus mz over izz. But now if we were to look at point beta, y is what? Negative now. Okay, so now this is minus y. So this is equal to plus mz over izz multiplied by y. Right? Because minus and minus is positive. So this is what? In tension. Okay. So that is why, okay, not that's why. So you can see this part at beta is also in what? Tension. Okay. Now, any questions so far? Anyone? Okay. I don't hear question. So now, if now, okay, the transformation is still fixed. Okay. So now I still do our transformation still fixed. So this is still our x, y, rotation about z. Now, let's say now I give you another different situation now. Okay. Now the situation is such that the curvature now, okay, is gone this way. Now the bending has gone this way. Hey. Now the bending changed. The bending has gone this way. Right? Now the bending has gone this way. Again, then we have our neutral axis, or centroid, sorry. Focus on the word centroid, not neutral axis. Okay. Centroid. So this is our centroid. Right? And again, the point alpha and beta did not change. Alpha is still over here. Okay, beta is here. Right? Now the center of curvature changes. Right now, as you can see over here, now becomes the center of curvature. Okay, so when that is the case, right? So that's the center of curvature. So when that is the case, I do apologize. I think you guys might be having some feedback from the other computer. Okay. So when that is the case, okay, relative to the center of curvature. Now, watch this, okay? Over here is your what? Y positive, right? So this direction going this way from the centroid, that is your Y negative, right? So by observation, you can see that the top part now is your tensile part. Your bottom part is your compression part. Okay. So now, if we strictly apply the formula, now I'm going to show you the bending moment arrow. Okay. So this is the bending moment arrow now. Okay. So this is your MZ. This is your MZ. Okay. I want you all to watch this. Okay. Over here, we also have our bending moment. Did I draw the bending moment arrow? Nope. Up here, I'm going to draw a bending moment arrow. Okay. So our bending moment arrow is over here. MZ. This is also your MZ. Okay. I think I drew it on the figure before. Okay. So I drew it. So it's the same thing. Okay. So what you can see down here, right? What you can see down here now, right? So if we look at stress X at point alpha now, right? So this is equal to, still put in the minus MZ over IZZ. Now, can anyone tell me, is alpha point positive or negative now? Anyone? Anyone still alive out there? Or you can type. Yes, you're right. It's negative. So this is equal to MZ or positive MZ over IZZ multiplied by Y. So it's positive, means it's in tensile or tension. And stress X at point beta, right? So this is minus MZ over IZZ. Now point beta now, Y is what? Y is positive. Okay, Y is positive. So you put positive Y. So you have minus MZ over IZZ multiplied by Y. So now it's compression. Okay. So the next thing comes is you understand when is it positive or negative. Okay. But one thing I like you to see is regarding the moment arrow. Now I want you to see I want you to observe the moment arrow for both cases. Okay. I want you to observe this. Okay. You don't get this from textbook. Okay. I developed this concept, and it's easy to understand. And later on, when you have two axes of moment, you will not make any mistake. Okay. As engineers, especially mechanical engineers, we have to visualize. Okay. Not just apply formula. Okay. Like the shearing stress. Okay. It's through observation we develop those rules. Bending is the same. Okay. So what do I mean? So if we look at the moment arrow, can anyone tell me what you observe with the moment arrow regarding compression tension? Can anyone tell me anything? Looking at the moment arrow, can you observe what is the similarity? Anyone? Anyone?
The moment is always in the direction of compression forces.
Okay. Vin got it right. Okay. If you look at moment arrow in the direction of compression, partly right. What does he mean? Okay. If you look at the head, this is the head of the arrow, right? This is the tail of the arrow, right? The head of the arrow is where you got the sharp point. The tail of the arrow is where you have just a dot. the head of the arrow is always in compression. If you view the diagram below, the head of the arrow is also in what? Compression. Can you see that? The tail end of the arrow, okay, the tail end of the arrow is always under tension. The tail end of the arrow over here is also under what? Tension. So we have developed one rule, okay, by observation. Okay, so it's always the fact, okay, I'm going to write down here, it's always the fact that the head of the moment vector is always in compression, right? And the tail end of the moment vector is always in tension. Okay, I want you to observe this. Okay, so if you understand this rule, the head is in compression, the tail is under tension, you don't need to bother about this anymore. You don't need to bother about this set of formula. Not bother. You don't need about worry about this formula now. Okay, you don't need to worry. What do I mean by no need? You no need to worry about the sign now. Okay, by looking at the moment vector, you know whether is it tension or compression. I find this easier to deal with it. Is because later on, as I say, you have multi-axis bending. It can get really what? Confusing. Okay, so I'm telling you what will help you later on. Okay. Now, so the next thing that we're going to do, okay, is why or where is the orientation of stress X? Okay, so where? So remember, I just explained to you why is this minus sign, and I also taught you how to visualize tension or compression. Okay. Next, what do we mean by stress X? What is this stress X that we're going to find? Okay, we already know what is Y. Okay, I just show you what is Y, and we also know what is IZZ, IYY. If not, I will elaborate later. Okay, now the next thing is this. Okay, the next thing I wanted to explain is where is stress X. Okay, we are trying to calculate this stress X, but what is this stress X? Okay, so again, we draw our simply supported structure. Okay, this is a simply supported structure. Point A, again the same, point B, and this is our point C, where we have a load coming down. This is our PY. So we draw our transformation, X, Y, rotation about Z. Okay, so now I'm going to take an element. Okay, so an element is a section of interest. Okay, okay, so this is known as our element now. Okay, so now I'm going to sketch this element. Okay, I'm going to sketch this element now. Okay, so I think you have seen an element before in the shearing stress. Okay, this is not the first time, right? So this is our transformation. Okay, X, Y, and this is rotation Z. I think we've seen element before. I think I did draw. Let me try to recall. Yeah, see, we have drawn element before in our week 3. So you guys know what is an element. Okay. So from here, right, we are trying to find stress X. So stress x is x in this direction. Okay, so this is stress x, right? And this is our stress